Morning guys, I just want to make an additional video for 5.6 day 1 just to show a little bit more practice to make sure we're understanding the process here. On Monday I will post 5.6 day 2, which is a little bit more complicated of an example of using substitution. Now this worksheet that I posted is intended to be practice for both days, so you will not have additional practice for 5.6 after this. You will have a quick review, just a couple of questions on Monday along with the lesson, getting you ready for just a short quiz on Wednesday, just a few practice problems to show you understand 5.5, 5.6, and then we're done for the quarter. So the first page of this worksheet, they have this additional term here. Right after the semicolon, it tells us what u is. So basically they're telling us what the inside function is, and that's our starting point. So if u is negative 3x to the 5th minus 1, du, the derivative is then negative 15x to the 4th dx. So that is exactly what I needed because I already had my u. So I can rewrite the entire integral as a u to the 5th, and then the negative 15x to the 4th dx together is replaced with du. So I've simplified my integral to a single term in this case that I can use power rule for. So u to the 6 divided by 6 plus c. Negative 3x to the 5th minus 1 all to the 6th power divided by 6 and plus c. Okay. Let me pick numbers 5 and 6 now. So 5, if my inside is u plus ln x, the derivative of 5 is 0, and the derivative of ln x is 1 over x dx. So that gives us the other piece of the integral. So now we just have integral of u to the 5th du again. So it's identical to the one that I just did for you. It goes to u to the 6 over 6 plus c. And then it goes to 5 plus ln x to the 6th power divided by 6 plus c. Okay. So now here, this one definitely is a little bit harder to see because of the way trig to exponents is written originally. So let me take a second and show you how this term right here, remember, is secant of 4x all to the 4th power. So I think if it was written in that way to begin with, it would be a little bit easier to identify the inside. So if I continue now, du, secant derives to secant tan, and it's secant tan of whatever is in there. Secant 4x, tangent 4x, and we have an inner prime. We also have to multiply by 4. I'm just going to put that in the front. So, and we have a dx, I'm sorry. So again, those are the additional things I have in my integral. So now my integral becomes u to the 4th du. u to the 5th over 5 plus c, and secant of 4x all to the 5th power divided by 5 plus c. Okay. The second page, it's the same thing, but they don't tell us the u. So I'm just going to start you off, for example, number 9, like the original notes. U would be the inside, negative 3x cubed plus 1. This would be your u, 3x to the 4th plus 4. Negative 4x cubed plus 2. 3x to the 5th minus 3. Negative 2x to the 4th minus 4. E to the 4x minus 4. 4x plus 5. 2x plus 3. So the last couple are the ones where they get a little bit harder, but I actually did show you this. They're just a little bit harder by a factor, by a coefficient. So you can always multiply or divide by a number to get it to match up exactly, or wait until Monday's lesson to finish those ones out. Okay, hope this helps. Another reminder, I sent an announcement, but I will be going through Gradebook. I have to close things out. There's a lot of people with 1 or 2 things missing, and then there's some people with a lot of things missing. So please make sure you're checking Gradebook and getting me everything you can. Of course, there's leniency and flexibility at this point. but just communicate with me